All right, hello, ladies and gentlemen. We are getting ready to do 4.7, which is identifying linear and nonlinear functions. So we've already really talked about linear functions, and they have graphs that are straight lines. They have a constant rate of change. So linear functions have a constant rate of change. So that's what we know right here. It says linear functions, and their rate of change is constant. Okay. Nonlinear functions are functions whose rates of change are not constant. They are not increasing or decreasing by the exact same amount. So we're going to be looking for increasing or decreasing by a set amount. So that's kind of what we're going to be looking at right now, and it's going to be super easy as we kind of go through this. So I want to go ahead and look at example 1 and 2 together at the same time. And it's having us do, if I can get my screen to do what I want, is asking us to see if these tables show a linear relationship or a non-linear relationship. And I just want to point out how right here, each side, we've done this so many times, we've noticed it's decreasing by 15 on this side, and this side is increasing by 2. And so since our rate of change is constant on both sides, you have to check both sides, we could decide that this is a rate of change of negative 15 over 2, decreasing by 15 over an increase of 2 each time. So this would represent a linear relationship. If we were to graph these points, they would make a straight line. Okay, so for problem 2, we're going to look at see how things are changing. Well, from 1 to 16 is an increase of 15. And then we go from 16 to 49, which is an increase of 33. And then 49 to 100 is an increase of 51. Now you might stop there and go, this is not linear, but you have to check this side, and then you have to compare intervals. Okay, so since this side is constant, 1 to 4, 4 to 7, 7 to 10, as you can see, an increase of 3. Since my domain is a constant rate of change and my range is not constant, this would not be a linear relationship. So keeping that in mind, if we were to graph these points, what you're going to notice is, I can get rid of this, I guess. What you're going to notice for these points is it kind of does a little bit of a curve. So it kind of does like that, a little bit of a curve. It's not linear. It does not make a straight line. So I want you to pause the video, and I want you to do the got it problems below. And you are going to type in, we'll do that later. We won't type in those answers yet. We might do a different got it problem. So pause the video, do problems A and B, and then start the video to check your work. Okay, I have done the got it problems for A and B. I found my rate of change for my domain. It's increasing by 5 on problem A. My range, or my y values, are decreasing by 4. And so since it is constant on both sides, I said yes, A is linear. It has a rate of change of negative 4 over 5. Remember my change in y over my change in x. So this over this. Over here, my domain, or my x values, had a constant rate of increasing by 2. But my range did not. My range showed an increase of 2, then an increase of 6, then an increase of 10. So there was no constant rate of change here. So these points would not create a straight line. Okay, so if you don't understand that, you can ask questions. Okay, I went ahead and turned to page 329, or went to the top of 329 for example 3. Use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function to its age in weeks. So again, it's just asking you to find if it's linear. Let's just find how things are changing. So what we notice here is this is increasing by 175, but then this is increasing by 185, and then this is increasing by 135. And then this is just increasing by 100. So none of these are constant, and yet we can see that our weeks and age is increasing just by 1 week. So it is not a linear relationship. Super easy. Okay, so try the got it problem down below. Go ahead and pause the video And this is what you're going to type in an answer to. So I'm not going to go over this problem. All I want you to do is tell me if it's linear. And if it's linear, tell me the rate of change. So is it linear? Yes or no? And if yes, tell me what m equals. So that's what your assignment is for your points on this video today. If it's no, just say no, not constant. Okay? So that's what you need to do. Tell me yes and the rate of change, or no and not constant. So pause the video and do that work and be ready to type that into your answer. Okay? I'm going to go ahead and since you paused, and then you come back to it, we're going to go ahead and move on to example 4. A square has a side length of s inches. So I'm going to draw the square just to show you what it means. And we know a square has the side length the same. So its length and width are the same dimension. So they're both s. So make a table to show the area of a square for side lengths of 1 inch, 2 inch, 3 inch, 4 inch, and 5 inches. So you realize we're going to do s times s, side times side, or we could look at it like side squared. That's why they have inches squared here. So if my side length is 1, I'm going to do 1 times 1. The area would be 1. If my side length is 2, 2 times 2 is 4. If my side length is 3, 3 times 3 is 9. So as you can see, plus 3, plus 5, plus 9, plus 11. Okay, so it is not constant. This side is constant, this side is not. And look at my graph. It's a curve. Okay, it is non-linear. So we're going to turn the page now, and we're going to go to the top of page 330. Or I'm going to turn the page. Maybe I'm not sure if it's you turning the page. We're going to go to the top of 330, and we're going to do the got it problem. This time it says a square has a side length of s inches. Oh, it's the same square. We have the same square, and we have s inches. Okay, so that means all my sides are length s, no matter what that is. The perimeter of the square is a function of the side length. Okay, does this situation represent a linear or nonlinear function? Explain. So I'm going to have you create a table and determine perimeter for, this is going to be my side length, and this is going to be my perimeter. You want to do a perimeter for a side length of 1, 2, and 3, and compare and see if it's linear. So pause the video and then come back and check your answers when you're done. Okay, I have written out the formula for perimeter. Just want to show you that it's adding all the sides together. We have 4 sides that are all length s. So I did side plus side plus side plus side. And I noticed that since they're all 4 the same, I could just do 4 times my side length to give me my perimeter. Since I'm adding 4 s's together, I can just do 4 times s. So I completed my table. If all the side lengths are 1, 1 plus 1 plus 1 plus 1, or 4 times 1, my perimeter would be 4 inches. If the side length is 2, my perimeter would be 8 inches, because 2 plus 2 plus 2 plus 2, or 4 times 2. And then if my side length were 3, my perimeter would be 12. Then I wanted to point out, compared my rate of change here. This is increasing by 4. This side is increasing by 1. So I said, yes, it's linear with a rate of change of 4, which makes sense because look right here. If my perimeter equals 4s, then I've got a rate of change right there in front of my s, showing that my rate of change should be 4. All right, you can pause or you can stop the video, type in your answer to that other got it problem. Make sure you get your points for this, and then you can start your assignment, okay? So your assignment is going to be on page 332 and 331. Please remember that you are having a quiz after this. You're taking a quiz to see if you've understood 4.5, 4.6, and 4.7. So I would like you to do problems 2, 4. I'll write them down here in a second. 2, 4, 5, 6, 7, and 8. Okay, they're all pretty easy. So we're going to do page 331, problems 2, and then 4 through 8. So I'm letting you guys skip 1 and 3. I only want you to do 2 and 4. And then I want you to do the rest of those. That is your assignment.